Hello, math students. Now that we have worked with exponents, we're going to move on into scientific notation, which uses exponents. And it's what we use a lot in science, which, is kind of where we get the name here, scientific notation, because we can work with really big or really small numbers and not have to deal with a whole bunch of zeros, either making a really big number, having a whole bunch of zeros at the end of the number, or if it's a really small number, having a decimal with a whole bunch of zeros before we get to the actual numbers that we need to work with. So in our scientific notation, it's going to look like what you can see on the screen right here. The number that we've got at the beginning is called the factor. So this problem, it's this 8.3. And that factor has to be at least 1, so 1.0 or more, but it's got to be less than 10. It can't be exactly 10, it's got to be less than 10. I want it so that there's one number after the decimal. I'm sorry, one number in front of the decimal. Like 8.3 is fine. 18.3 would not be okay because it has to have just the one digit, the 8 in this case, in front of the decimal. We can have more digits after the decimal. It doesn't matter how many we have after the decimal. Then we're going to use multiplying, and this is like the only time that we use an X for multiplying. Personally, I don't really like it. I wish they would just go to a dot right there, but this is like the standard way of writing scientific notation. Realize that in scientific notation, we're not using variables. So that's not going to be an X as a variable. That's our multiplication. And then we're going to multiply by a power of 10. In this case, it's 10 to the negative 7th power. That tells us how many places we have to move the decimal to get it back into standard form, a regular number. Okay, but this is what our scientific notation is going to look like. And when we talk about this, I will be saying the word factor quite a bit when we talk about like making sure that it's the right size, that 8.3, that's kind of a big deal. And then again, the exponent that's on the 10 is going to matter. But it's always going to be a times 10 to some power at the end of our scientific notation. Here you can see I've got the same number, 2.345, to different powers. If I have a positive exponent on the 10, now both of these columns start with 10 to the 0 power. You know that 10 to the 0 power is equal to 1, and multiplying by 1 doesn't change anything, which is why the number that we have right here is exactly the same as what we started with. Same thing here. The number that we have right here is exactly the same thing as what we started with. Right? So because it's a 10 to the 0, it didn't do anything. When I have, and let's just focus on the left column for a second, when I have a positive exponent, 10 to the first power is really multiplying by 10. The nice thing about multiplying by 10, or multiples of 10, is that it just moves decimals. That's why we do this with scientific notation, so we can just move our decimal. So in the second number, I have my decimal starting right here, and then because I multiplied by 10 to the first power, it does move it over one place. That number is really 23.45. If I multiply by 10 to the second power, which is really 100, it's going to move it over 2 places. So you get 234.5. Multiply by 10 to the third, it's going to move 3 places. Now, it's nice that you should know that 10 to the first is 10, or 10 to the second is 100, or 10 to the third is 1,000. But it's not even all that necessary for scientific notation. That exponent is telling me how many places to move my decimal. So in this bottom one, 2.345 times 10 to the third, again, that's 2.345 times 1,000, which would give me 2,345. But it's also just saying move 1, 2, 3 places and done. I don't actually have to multiply. All it's talking about is just moving the decimal. Now, multiplying by 10 to a negative exponent. 10 to the negative 1, we know that is 1/10. 1 over 10, which is the same as 0.1. Multiplying by 0.1 would make this smaller, which is why my decimal is going to move 1 place to the left. That does make it smaller in place value. 10 to the negative 2, that's 1/100th, which is going to move it 2 places, but again, it's getting smaller because I'm multiplying by something that's less than 1. 10 to the negative 3, 1, 2, 3 places. So we are getting smaller as those exponents on the 10 get smaller. right? If we've got a negative exponent, it's going to get smaller. The exponent just tells you which direction to move. And I'm even going to say, I don't even need you to memorize, if we're moving to the left or moving to the right, because when we reverse this, if I would start with a regular number and I want to change it into scientific notation, I don't want you to have to memorize, okay, so I moved left going this way, but I'm going to have to move right going this way. I want you to think about big numbers or small numbers. When I have positive exponents, like over here, my numbers are at least as big as I started with or getting bigger. Just move your decimal so your number looks bigger. So in this case, they'd be moving to the right. When I have a negative exponent, like I do over here, I guess not the 10 to the 0 part, it's going to get smaller. Negative exponents are small numbers. Move your decimal so that it gets smaller. So I'm going to be giving you some numbers and asking, are they written in scientific notation? As long as it has the times 10 with some power, that part we don't have to worry about. They're not going to try to trick you with that part usually. The thing that I have to worry about is the factor. This 5.9, that is 1 or more, and it's less than 10. I've got one number, the 5 is in front of the decimal. Yep, that one is in scientific notation. I don't need that long explanation. The factor is the right size. For B, I know that it looks like there's a 0 there, but I'm talking about a non-zero digit. I mean, one number that's in front of the decimal. This is not scientific notation. 0.9 is less than 1. Remember, it has to be 1 or more, but less than 10. So this one is, no, it's not in scientific notation because that factor is too small. These questions are always about, is the factor the right size? Is the factor too small? Is it too big? Or is it just the right size? Kind of like Goldilocks going on here. So if I have scientific notation, and we're going to be changing it into standard form, a regular number. That's what this is all about. And again, I'm going to say, I don't need you to memorize the left and right part. You can if you want to, but I would rather that you're thinking about these in terms of big numbers or small numbers. So for letter A, 3.22 times 10 to the negative fourth. 10 to the negative fourth tells me, because it's a negative exponent, small number. And the exponent tells me how many places to move my decimal. So I'm going to just rewrite that number over here. I have 3.22. I'm going to move 4 places, and since it's small, I'm going to move to the left. 1, 2, 3, 4, and then kind of got squished there. Fill in those little swoopy things with zeros. It's 0.000322. Okay. The whole thing that showed up right there with the absolute value part is saying, so the negative 4 part still tells me I'm moving 4 places. The negative is telling me that it's moving to the left. For letter B, 7.9 times 10 to the 5th. So the 5 is telling me it's going to be moving 5 places. My decimal is starting between the 7 and the 9. So it takes 1 place just to get after that decimal. And then I need 4 more places to move 5 places total. So there's 1, 2, 3, 4, 5. And then usually when we've got big numbers, we do like to have commas. It makes it a little bit easier to read. But 790,000. For these 3, again, I'm looking at, are they actually scientific notation? I have kind of one of each option here. So number 1, by the way, all of these start with a times 10 to some power on the right side, so that's all good. I'm looking at the factors, right? 1.8, that is just fine. I've got one number in front of the decimal. Boom. It's all good. The factor is the right size. For number 2, here's my factor. Is it more than 1? No. I don't have a non-zero number in front of the decimal. That factor is too small. You can say the factor is less than 1, or you can just say it's too small. In number 3, I don't even see a decimal. It is there. It's right there, in fact. But I've got 3 numbers in front of that decimal. That factor is just too big. So no, it's not scientific notation. That factor is more than 10. Well, yeah, by a lot, right? Changing these numbers into scientific or into standard form from scientific notation. Again, for number 4, positive exponent tells me it's going to be a big number, right? So I'll have the 4 and the 8. The decimal starts right here. 1, 2, 3, 4, 5. Fill in the zeros. Or you can think it takes me 1 place to get after the 8, and then I need 4 more. So that's why I've got the 4 zeros. So there's my answer. For number 5, it's going to be a small number. It's a negative exponent, so that means I'm moving to the left 7 places. And again, when I do this, I tend to just say, well, it's going to take me 1 place to get in front of the 8. I still have 6 more places to go, so I would just write down my decimal, 6 zeros, and then 8052. If you want to just move it over and do the little swoopy things to fill in the zeros, you can. I already moved 1 place to get in front of the 8. 2, 3, 4, 5, 6, 7. There's my decimal. 1, 2, 3, 4, 5, 6 zeros. Unfortunately, with really small numbers, we don't use commas, but make sure you're counting that there's 6 zeros between your decimal and then the 8052. For number 6, with an exponent of 11, it's going to be a big number. My decimal has to move to the right 11 places. Now, the trick on this one is that I don't see a decimal again, which means it's really right here. If I have to move 11 places and I don't have any extra numbers to worry about, it's just going to be a 2 with 11 zeros. Okay? Then for number 7, negative 13 for an exponent is going to be a really small number. Again, it'll take me 1 place to get in front of the 9. And then I still have 12 more places to fill in. So you can do the little swoops and all, fill in all the zeros, or you can just put a decimal and then it'll be 12 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros, and then your 9 and then 3. Notice, I forgot to mention this earlier, notice there's only 1 decimal. Not that I should have to say that, but there are some students that tend to leave a decimal like right here, and they have another decimal up here. That is not okay. You can't have 2 decimals. The decimal that was between the 9 and the 3 moved. It's not there anymore. Today's problems are from a textbook page, so it's a PDF in Schoology on page 440 and 441, 2, and then 6 through 24. A lot of them are just saying, is it scientific notation or not, or just writing it into standard form, 26 and 27. The answer keys in Schoology, just like always, and then there's going to be a quick learning check for you. If you need any help, let me know.